Hello. So today we're going to be covering EEPROM. So EEPROM stands for Electrically Erasable Programmable Read-Only Memory. This is a type of non-volatile memory. Non-volatile means that it can retain stored information even if power is removed. So this makes it really useful for stuff like thumb drivers, SIM cards, which are the ones that have the card in your phone, SD cards, smart cards, the ones I use to pay, the payless contact card system, and also remote keyless systems. So if you didn't know, now you know it. Your Arduino can save data even when it's power off. Now, I'm gonna try to explain how this one works. Just for you to know, the thing that you see on the right, it's memory. I like to think about it like a huge building where every byte it's one room. So think about memory like a room that's 1,023 floors tall. Our Arduino can hold 1,024 kilobytes of EEPROM. So you may wonder why I have only 1,023 on my right. That's because I'm starting at address 0. So every address in memory, it's like a floor in a building. It can save 1,024 8-bit long values. That means that those numbers can go between 0 and 255 because 2 to the 8 minus 1, it's equal to 255. So if you want to save values like 500, 1,000, 3,000, you may need to save it in parts, in the first 8 bits in one address of memory and the next 8 bits in the other address of memory. To keep things simple in our lab, we're just going to be saving values that will go between 0 and 255 to make our life easier. So as you can see, every byte has an 8-bit storage space, and that's called an address. That's what you use to save data, but this is going to make more sense once we start to see examples. So let's move on. How do we code it? Well, there's some functions, but for our lab, we're just going to focus on 3. EEPROM write, EEPROM read, and EEPROM update. Make sure that when you write your code, you include the EEPROM header library, EEPROM.h library. So, how does EEPROM write works? Well, this function needs 2 arguments. You need to write the address and the value. So, as you can see on the left, first we have all our memory with zeros. By the way, every time that you reset your EEPROM, you're gonna have zeros in your memory. So it's all full of zeros. Then we're gonna write the instruction EEPROM write 13, where 1 it's the address in memory and value it's the number that you want to save. So as you can see in this example, once we write instruction and it's processed by the Arduino, it's gonna save a number 3 into address number 1. That's how EEPROM write works. Here is another example. Now, as you can see, our memory on the left, it's in the last state where we left it in the first example. That 3, it's already there. But now we're gonna write in address 2 a number 30. So in my left, I have my 0 in my address number 2, and when I go to the right, once I process instruction, now I have a 30 saved into my address number 2. Now, how does EEPROM read works? So we're gonna declare an 8 bits value, and that's gonna be data. It's a variable called data, and it's an 8 bits long, so it can save up to 8 bits, a number that can go between 0 and 255. Let's say that data is equal to 0, just to have something there. So what we're gonna do is that we're gonna read an address, and then we're gonna save whatever it's inside of that address into data. So as you can see, we have 30 in my address number 2. So after I execute this instruction, I read what's in address number 2, which is that 30. That 30 will be saved into my data variable. And now data is 30. And that's how it works. Here is another example. Now we're gonna read data from address 1023. So here we're going to, first we had a 10 there, so that 10 is in address 1023. When we process the instruction data now, first it was 30 because that's what we have in the previous example. So we had 30, but once we read the address, that 10 gets loaded into data and now it's saved there. So now let's go over update. Update, it's gonna change the value if it has a different value than the one that you want to update. In this example, first, in address 0, we have a 0, and we want to update to 125. So since we had a 0 before in address 0, and we want to put a 125, it's gonna update it. So it's gonna change it. But in this case, we want to update address 1021 to 0. But as you can see here in the previous state, we have 0 already. So nothing will happen because it has a 0 already. So in theory, EEPROM should be a little bit faster than write because it's going to avoid the action of writing, which is the one that takes more time. So that's all that I have for you. Now let's move on to some examples.